that first problem's done, let's get into the second one. So this one has a lot of parts, but it's pretty much the same problem that you had in the previous. So problem one and problem two are pretty much the same in terms of what she's asking, but I will say this one she is forcing you to use the quotient rule, which again I'm not a fan of it, and you'll see why when we do this problem. But I um, and I prefer to change quotient rule to a product rule problem any day. That's what I would like to do. That's what I prefer to do. But I mean, this is what she wants, so let's give her what she wants. All right. So h of x is equal to 2x divided by the natural log of the quantity e plus x. So the domain of this one is not easy. So you have to work with this and kind of break it up and work with and try to establish the actual set by breaking it up in parts. And the way to do that is to, if you notice that, well, let's just do part C right now, right? So of course, h of x is equal to f of x over g of x. So f of x is equal to the numerator, which is 2x, and g of x is the natural log e plus x. We can do the derivatives later, but ultimately, to do the domain, to do part A, the domain of f is going to be all reals. And it's all reals because it's a linear function, right? So linear lines go on forever in the x direction and in the y direction. So it's all reals, right? So all reals. The domain of G is a little bit different. Now, the domain of G is going to be based on what's inside the parentheses. So the natural log of e plus x, you can get any value from y as long as the x value is defined, right? But in order for that to happen, the inside has to be greater than 0. It must be greater than 0. So if you have natural log and then you have the inside function, the inside function must be greater than 0. So in this case, e plus x is strictly greater than 0. Cannot be equal to 0 because 0, the natural log of 0 is an undefined value. So every value must be greater than 0. All right, so if that's the case, then x must be greater than negative e. So your domain is from negative e, does not include e, which is why you see the parentheses, to positive infinity. So the domain of f divided by g is the intersection or the overlap that f and g have. Well, the overlap right now is with the restriction on negative e to positive infinity. Right? So I can't use all reals at this point anymore. But all reals does include this interval of g, which is from negative e to infinity. But we also must be concerned that because it's f divided by g, I must make sure that g does not equal 0 either. So I have negative e and natural log of e plus x does not equal 0. So now I have to take care of this down here. I have to take care of this because this may also restrict my set again. It may interfere with this. Well, we'll find out. Maybe it does, maybe it doesn't. But it will. All right, so I have to solve this problem right here in a way that it tells me a value of x that would give me 0 if I threw it in the natural log function. All right, so let's solve it. The natural log of e plus x cannot equal 0. So remember, the natural log, the base is e. So what I normally do is drop your natural log, the e becomes the base, the 0 becomes the exponent, and that becomes e plus x cannot equal e to the 0. So that means e plus x cannot equal 1. So x cannot equal 1 minus e when I subtract e on both sides. So I have another restriction. So that means when I look at the value of negative e, 1 minus negative e is in this interval. So I got to break it up. So the domain of f divided by g is from negative e to 1 minus e union, because I can't include that value, because that's why I have open parentheses, 1 minus e to a positive infinity. Well, how do you know that this works this way? Well, you'd actually have to graph it to see what's going on. So I already had it set up, so I'll graph it, and this is what the graph looks like. So if you notice, you have, this is about negative 3. Well, negative e is about negative 2.817, right? So it's very close to the negative 3. And then if you come around here, it's really close to going on to unbounded negatively, or going on to negative infinity in the y direction when we get around negative 2. So 1 minus negative 2, 1 minus 2.8 would be about negative 1.8, right? So this part goes from like negative 2.8 to negative 1.8, and then it goes on forever from 1 minus e, which is about negative 1.8. Right, so this one was not an easy one to do, but it's easier when you break it down into steps. So whenever you have a rational function, make sure you look at f, look at g, find the intersection of those, and then find out if you have any restrictions when g is equal to 0, or does not, well, set it so that g does not equal 0. All right, so that took care of the first one. So part B, what's that one? What is h of 0? So when we go back to the problem, I have h of 0 is equal to 2 times 0 over the natural log of e plus 0. So that's 0 over the natural log of e, which is 0 over 1, which is 0. All right, so h of 0 equals 0. So the point that I need right now is a value of 0, 0. So 0.00. And that's really going to help you when you have to find the equation of the tangent line, because now you know that it's going to go right through the origin. So it's going to be like 2x, 3x, 4x, 5x, and you don't have any y-intercept because it's through the origin, or you don't see it. So let's look at part C. Part C says what? Note that h of x is a quotient of the two functions. What are the two functions? Label them f and g, and then find their derivatives. All right, so we already took care of that, right? So we already did we kind of did half of it. So f is 2x. G is equal to the natural log of e plus x. So let's look at f prime. So the derivative of 2x is equal to 2. That's not 0.2. I already knew that was going to happen. And now let's look at g prime. All right, so we have to work the chain rule. And the reason why we have to work the chain rule is because the natural log is the outer function. And then you also have a function inside of the natural log function. So you have a linear function inside. So you have a composite function. So you have to take the derivative of the outside function. So whatever, so if the function is natural log, the derivative of natural log is 1 over whatever's inside. So that's e plus x. And then let's take the derivative of the inside, which happens to be 1, because the derivative of e plus x is equal to 1. So you are simplified to 1 over e plus x. So now she wants you to find the derivative. All right, so let's find h of x. All right, so the quotient rule, I mean, this one's going to be a little nasty, but it's g f prime minus f g prime over g squared. So the way that I've always done it, and just like I did the product rule, the first times the derivative of the second plus the second times the derivative of the first, I always do it as I do the computation. I do it this way. I do bottom times the derivative of the top minus the top times the derivative of the bottom. Tops and bottoms, divided by the bottom squared. All right, so that's how I've always calculated that one. And since we already calculated all of the parts, we can just simply plug it all in. So h prime of x is equal to g, which is the natural log of e plus x, times f prime, which is 2, minus f, which is 2x. I'm going to put that in parentheses because right now I'm going to get 1 over e plus x for g prime, and then that's all over. Okay, now this is not going to look cool, but this is how you have to represent the natural log of e plus x squared. Now what a lot of people would do is they would say natural log e plus x squared. But when you do that, you only think that this is being squared. The inside function is being squared. I need the entire function to be squared. So this is a big old hell no. You can't do that. That's not how that works. It's the entire quantity being squared. Right? So let's simplify this a little bit. So I have 2 natural log e plus x minus 2x over e plus x all over natural log e plus x quantity squared. I can simplify this some more, and I will, just so that, or yeah, I'll simplify it because she wants a formula for it, right? Yeah, make a formula. So you don't have to, you can calculate a value, but what you have to do right now is a little bit different. All right, so I have 2 natural log e plus x minus 2x over e plus x over the quantity L, natural log e plus x squared. All right, so I want you to know that we can break up this as 2 fractions, right? So let's say I have 3/7 plus 2/7, right? That's the same thing as saying 3 plus 2 over 7, right? So I can break up the fractions, or I can take 2 fractions and make them into 1, or take the 1 fraction and break them up into 2. So in this case, this is what I'm doing. So right now, if I have 5 minus 3 over 7, what do I actually have? I have 5/7 minus 3/7. Right, so that's what I'm going to do here because it's going to help me simplify stuff a little bit later. All right, so I'm going to erase this real quick. All right, so this is going to be 2 natural log e plus x over natural log e plus x quantity squared minus 2x e plus x over natural log e plus x quantity squared. All right, so I have a natural log and a natural log that cancels, so then I'm left with 2 natural log e plus x minus, so you could kind of do this 2 ways. What I'm going to do here is I'm going to multiply top and bottom by e plus x, because that will get rid of the fraction in the numerator. So I'm left with 2x times e plus x times the natural log e plus x quantity squared. Ugh, what a nasty derivative. So that's your actual derivative, which is why I don't like the quotient rule, because the product rule would have kind of gotten you there a little bit better, a little bit cleaner. So now I have to find h prime of 0. So if that's the case, then I have 2 over the natural log of e plus 0, so that's e, right, minus 2 times 0, so whatever's down here is going to make it 0, but we need to make sure, well, it will be 0, because this value will be a real number. So I have e plus 0, so that's e. I have e times the natural log of e squared. So that's 2 over 1 minus pretty much 0. I don't, 2 times 0 is 0. Anything, and I already know that that's a real number. So it's actually e. It simplifies to e. So that gives me that the slope of the tangent line at 0 is 2. So quickly, I know that my point is 0, 0, and my slope of the tangent line is equal to 2. So y minus y0 is equal to mx minus x0. So in this case, both of these are zeros, so what I'm actually going to get is y equals mx, and what's m? Y is equal to 2. So that's the equation of the tangent line. So yeah, we went through pretty much everything, right? Domain, we did that. H of 0, we did that. Quotient, we did that. Derivative, we did that. H prime of 0, we did that. And then equation of the tangent line. All right, cool. All right, so that one's number 2. I'm going to upload this one. And then probably based on looking at problems 3 and 4, I may combine them. I don't know. We'll see. We'll see how long it takes for me to do them. And make sure you watch this one, and then we'll get ready for the FaceTime. All right? Later.